So first up today, I'm very excited that we have Sam Brown, who is currently at the University of Tübingen. Her very last days there will be moving to Zandra very soon. And she will be talking to us about Zooms. And yeah, floor is yours, Sam.
Thank you very much. Okay. Yeah, thank you so much for having me. I can't even tell you how thrilled I am to get to be a presenter at the very first PAASTA conference, how thrilled I am that I was asked to come and speak about Zooms, one of my absolute favorite things in the whole world. I began working in this field 10 years ago, so I've got to see so much of the rapid expansion and innovation in Zooms in the past decade and a half or decade that I've been part of the field. And so as part of this talk, I really wanted to reflect on that and reflect on how the method has changed and innovated and grown into being a technique or from being a technique into a field of its own. I think what's particularly really exciting about this is that we've had so much growth in the way Zoom's supplied, in the methodologies in the past decade and a half. And now that we have societies like PAASTA, now that we have communities of people working to expand paleoproteomics, I can't even imagine what a Zoom's talk in the next decade and a half will look like. So I'm really excited to see that. Because I'm gonna be talking about lots of people's research, I put together a little document of all of the references that I'll be using. So if there's a paper that piques your interest, if there's a method you want to find out more about, I'll put the QR code here and I'll put it again a couple of other points in the talk so you can scan it. It's not a very well organized document, but I'll go back in and fix it up later today. But all of the references from the talk will be there at that link if you're looking for something specific. A little bit about me. I am currently the junior group leader for the Archaeo and Paleoproteomics Working Group at the University of Tübingen. We're part of the Institute for Archaeological Sciences, and this is my incredible working group. For the most part, we work on collagen-based objects, predominantly with Zooms, but also with some shotgun proteomic work as well. And we're interested mostly in the Pleistocene. My great love is large assemblages of fragmented bones. What little girl didn't grow up hoping to one day study large assemblages of fragmented bones? And I very luckily get to do that every day. But I know that this represents a very narrow part of the field of Zooms. So as I said, I want to kind of reflect on the field as a whole. I want to move beyond just looking at the Pleistocene because for those of you that don't use the method, for those of you that are interested, hopefully that will be a little more useful to you. But if I fall back into old habits, if I start talking about things directly related to the Pleistocene, my apologies. Now, as was mentioned, this is my current affiliation, but tomorrow is my last day at the University of Tübingen. And then I'll be moving here to Senya in Spain at the National Center for Research on Human Evolution, where a brand new paleoproteomics facility is being established. The facility itself will be world-class. So if you're interested, if you have project ideas, if you want to come and see the facility, please reach out, let me know, because I think it's going to be a really exciting place to be doing paleoproteomic research. But enough about me. Let's talk about Zooms. So in trying to create this talk, in trying to structure it, as I said, well, I kept running into the same problem. And that was talking about Zooms from the perspective of my research meant that I was talking about a tiny little part of a much broader community of research. And when I look at the ways that the method has changed in the past 15 years, you can really start to ask, what is Zooms? How do you fit Zooms into a 20-minute presentation? How do you sum it up in a simple way? And in particular, what was Zooms 15 years ago in 2009 when the first publications came out? And what is it now? How are the people who work in this field talking about it? How are they discussing it? And what kind of research are they doing? The first paper really truly did come out 15 years ago, almost to the date. We're almost on the exact 15th anniversary of the first publication in which the method was established and the first reference libraries were published. In that 2009 publication, the method was quite straightforward. So Zooms, for those of you that don't know, is a paleoproteomic technique that utilizes something called peptide mass fingerprinting. It's predominantly used in archaeological samples for taxonomic identification. And in this first paper, reference libraries for collagen in bones were published. The wonderful thing about collagen is it's present in lots of the archaeological materials that are frequently studied using Zooms. So we can use that same reference library for ivory, for dentine, for parchment, for hide. I'm probably forgetting something, for leather, for all of these objects that are collagen-based. So it was already quite a versatile technique, even in its first inception, even in its first publication. The method is quite straightforward. A small sample was removed from the bone, so a small bone chip. Uh, how much bone, I'm sure, is the first question that pops into your mind. Maybe between 10, 20 milligrams. If you have a ballpoint pen in front of you, it's about the size of the head of the pen. So a very small bone chip. In this first publication, the collagen was then extracted using acid demineralization, and then that demineralized bone was gelatinized, which allowed the collagen to move into solution. An enzyme is then introduced, which acts to cut these lovely long chains of amino acids into their smaller collagen peptides, and then it is measured. This is what a measurement looks like. Each of these peaks represents a different peptide present in the sample. We then go through, find the diagnostic peaks, and match them to a reference library that tells us that this bone belongs to a rhino. In that first paper, 32 mammals had their collagen reference databases published. And what was really fantastic about this initial publication is that it covered a lot of the animals that were frequently found at archaeological sites. So dogs, pigs, deer, rodents, all those sorts of things were present in that reference library, meaning that it was immediately applicable. And very quickly, the method grew. So this is a graph that I made for a paper in 2021. And you can see it's already horrendously outdated. It ends at 2019. But over a very quick time period of about 10 years, Zooms was being applied very widely to lots of different kinds of sample types, to lots of different regions. I looked up the number of citations for 2023 in which Zooms was used or discussed, or there was some kind of method development proposed, and it's over 260 citations for last year. So I need to make a much better version of this graph, because it's what was dozens of papers being published every year is now hundreds of papers being published every year. And so Zooms, as I said, I think of it not so much as a method, but more of a field of research that is being generated. This graph I published as part of my own first foray into really thinking about how the method had grown. And that was part of this standardization of Zoom's nomenclature that I published with my colleagues Katerina Duca, Matthew Collins, and Christine Corzo-Richter. And here we were contending with the issue of the number of peptide markers that had been established as being useful for discriminating between taxa. In that first publication, the markers were labeled A, B, C, D, E, F, G. But as soon as people started to identify new markers that were useful for identifying other species that were not on that original list, the nomenclature immediately started to get confusing. And so in this paper, we were trying to find a way to future-proof it, to create a labeling system that could be broadly applied. Now, whether or not we were successful in that can be debated another time, or at the end of this, if you would like. But this really got me thinking about how Zooms had grown, how much it had changed, and how the way we discussed it had changed. Even in trying to train people, talking about the names of the peptide markers, we kept hitting this roadblock of how do we describe them, how do we report them. What was also really wonderful about writing this paper was the community effort that went in behind it. Of course, there were us four co-authors that published the paper, but we reached out to labs all over the world. We sent versions of this draft to as many people who had time to read it, and we got really incredible feedback from dozens of, or at least a dozen researchers in writing this. In particular, in the acknowledgements of this paper, we thank Daniel Kirby, Frida Welker, Jessie Hendy, Maria Codlin, and many others for their help in discussing what the nomenclature could be, and discussing how we could best future-proof this simple part of Zooms, but what hopefully has become quite useful to people in the field. And that kind of thing has me thinking about the ways that we discuss Zooms and how much has changed. There are some pretty standard things that I used to say whenever I introduce Zooms to people. Number one, Zooms is most useful at making genus and family level identifications. Is that still true in 2024? The method is inherently destructive. That was something that we always had to talk about. Should we be drilling into this sample? Should we be cutting this sample? How precious is it? And how necessary is taxonomic identification? We also, in 2009, the first reference library was really aimed at fauna in Europe and Eurasia, and that stayed true for some time, but we now have this push to move reference libraries beyond those regions. And then maybe a controversial question. I don't think it should be controversial, but is Zooms only for collagen? And I want to discuss all of the different kinds of reference libraries that now exist for the method. So, what can Zooms identify? This is now an incredibly outdated slide that I used to show pre-2023. So only a couple of years ago, I would show this slide. I would put this fauna on here and I would say, okay, Zooms is great, but for the most part, we can only make genus and family level identifications. So all horses look the same, whoops, and domestic and wild types will also look identical in terms of their Zooms result. Now, what I say is, sure, that holds true most of the time, but really it depends on which species you're interested in differentiating. Which region are you working in, and what fauna do you think is likely to be represented in your assemblage? Because time and time again, we find that genus and family level identification has an asterisk attached to it. One really wonderful paper that has become a class favorite is this Jensen et al. 2020 paper looking at bone points from southern Scandinavia, where they identified a peptide marker that allowed them to differentiate red deer from other deer at the site. So a brand new marker that was specific to this region, specific to this assemblage, that allowed them to differentiate red deer. So can we separate deer from each other? Well, it depends on where you're working, what you're working on, and what species you expect to be present in your region. Returning to horses, last year this paper came out which demonstrated that if we use a different enzyme, if we move away from trypsin to cut our collagen and start using other enzymes, we may be able to make species-specific identifications if we digest the collagen in a different way. And here they were really successful in separating horses and donkeys from one another, something that we had always presumed would be impossible based on the earlier established reference libraries. So in 15 years, we go from having a fairly simple, straightforward reference library to having a much more complex picture of the kinds of identifications that we can make. So this slide now looks like this. If anyone is planning on finding a way to differentiate rhinos, please let me know and I will update this immediately. Looking beyond mammals, which were certainly the focus of the early reference libraries, very quickly we had reference libraries established for fish. In 2011, Christine Corzo-Richter and colleagues published the first manuscript demonstrating that Zooms was incredibly effective in making identifications for fish. And more recently, we have reptiles and amphibians. But one group that has always plagued Zooms research is birds. I can't even tell you the number of times that someone brought bird samples to our lab, asked if we could identify it, and I had to tell them, absolutely no. It's not possible to do Zooms research on birds. Sorry, it was attempted as part of the original 2009 study, but birds have far fewer amino acid replacements than other fauna do. And we rely on those amino acid polymorphisms between species. That's what we're doing when we measure peptides. We need those differences in mass to be able to differentiate. And so it was presumed that Zooms was not applicable to birds. You needed to use other methods to do it. And lo and behold, a few years ago, we get our first paper demonstrating that not only can we separate birds, we may even be able to separate fairly closely related species like domesticated chickens and pheasants, as was demonstrated by this Ida et al. Paper in 2020. Very quickly after that, we got an entire reference collection of bones from central Mexico in this Codlin et al. 2022 paper, looking at an assemblage of bird remains from Teotihuacan in Mexico. So already, what kind of fauna can we study? Well, lots of them, but we need the reference libraries, we need the investment in research to be able to do it. But this has already changed the way that we are identifying assemblages, and no longer do I just skip over the birds when we're looking at the big assemblages of fragmented assemblages. How big does the sample need to be? This is the question that I get asked all the time, and I don't know how to answer it. It depends. And it depends in large fact, thanks to what's happening to this cat here and the triboelectric effect. It used to be that we would drill a sample, we would take a small cut, no matter the methodology we were using, whether it was buffer or acid base, to extract our collagen. But now we have incredible examples of minimally and non-destructive methods, like this fabulous paper looking at parchment in pocket Bibles from 2015, where they used a razor waste to identify what the pages of these Bibles were made from. And one of my absolute favorite papers that if any of my students are, which they should be, if any of my students are in this call, I use this in every single class because I think it's such a wonderful application of Zooms, in the identification of these Middle Paleolithic bone tools. These are lissoirs. They're very rare. There are only a handful, half a dozen of them that exist in the world. And so drilling into them is just never going to happen. But here, they developed a method where we could use the bags and the boxes that these artifacts were stored on. Enough collagen clings to the plastic of these surfaces, we can rinse those off and identify them entirely non-destructively in a way that archaeologists are already storing samples. We're using the tools that already exist to be able to entirely non-destructively sample these. So how big does the sample need to be? It depends. Let's look, we need to go artifact by artifact. There is no general rule that we can give people now. And now the question that seems to cause the most debate, although I would argue it should not. Is Zooms just for collagen-based samples? Of course, the first reference libraries focused on collagen. It's one of the easiest proteins to extract. And from an archaeological perspective, we have lots of bone being produced at site. We also have pretty good preservation of ivory, leather, hide, parchment in much more recent periods. All of these things are available, and collagen is so easy to extract from these tissues. But very early on, after the original publication of collagen reference libraries, we started to get reference libraries for keratins. A lot of this work was spearheaded by Caroline Zalazzo and her team. And now we have reference libraries for furs and feathers and even marine turtle shell. If you're interested, you can find them all at these references. Alongside that, eggshell can be taxonomically identified using Zooms, or at least the same principles as Zooms. Also in 2013, we had the first publication of an eggshell reference library, followed up in 2017 by Presley and colleagues. And very similar to collagen, we can get these sort of broad genus level identifications, which are so useful in understanding how eggs were being used in the past. Another peptide mass fingerprinting technique that I would like to highlight is this work of surface coatings. I saw this popped up in the Slack chat a couple of days ago, and I was very excited because I really love this work. This has become a fixture of my own Intro to Zooms classes that I teach, and that is the characterization of these surface coatings that are protein-based. So coverings that are intended to protect photographs, to protect funerary art. I saw that recently Daniel Kirby and his group had published a similar paper looking at coatings on drawings. These use the exact same principles. The sample is extracted, the protein is digested, we measure it, and we match it to a reference library. So to me, I think all of these things fall under the Zooms category and really demonstrate that the flexibility, the inherent flexibility of this method and the range of tissues that it can be applied to. And this will likely keep expanding as more investment into developing the reference libraries grows. And on that point, I think the regions in which Zooms can be applied to, that's really where we need to start focusing and growing the technique. As I said, most of the reference libraries were created initially for this part of the world, but in more recent years, we see these reference libraries popping up all over the world. These are just a couple of them. There are far more. But in particular, as an Australian, very exciting to see that we have reference libraries for marsupials now, for bovids in Africa. So much of the work focusing on fish and amphibians and reptiles are for sites and regions outside of Europe. And of course the birds. All of the bird publications so far, I think, are either based in Japan or in South America. So wonderful expansion of the reference library. And the more this is done, the more focus that is put on this, I think the faster Zooms will continue to grow and we can go global with this method. So what is Zooms? I think of it as being an incredibly flexible approach to taxonomic identification of protein-based samples. I don't think we need to put restrictions around the tissues or sample types, but the idea, the principle is one that is incredibly flexible, and we have a lot to thank to the initial authors of the method for creating a system that could be replicated and molded and allowed to evolve in so many different ways. But yes, reference libraries, I think, are key to the continuation of that growth. So thank you very much. Again, here is that code where you can go find all of the references here. And thank you so much to the organizers for asking me to come and talk about Zooms. Thank you.